Ancient Tech 1 to 3, Stone, Light, and Water. Start at Giza, where myth likes to outrun measurement. Here's the sober lane. Set aside the popular power plant claims and hydrogen maser ideas. Focus on what's measurable. The blocks align with true north to a fraction of a degree. Internal passages exhibit notable acoustic behaviors, stone volumes shaped in ways that produce predictable effects in tests. Meanwhile, chemical residues reported in certain shafts and chambers remain debated in meaning. So we ask a different question. What job does precision serve if not a power grid? Timing, signaling, the ability to coordinate labor and ritual through predictable cycles. What nobody knew at the time was how effective that looks over decades. A society that can lock architecture to the sky can lock the calendar to resources, harvests, taxes, stone deliveries, by design. And when you wrap function in sacred narrative, you protect it. You don't discuss alignment as logistics, you stage it as ceremony. Utility hides in plain sight. While that was happening on the Nile, across the waterlogged fields of the Boyne Valley, builders carved a corridor that waits all year for a few minutes of sun. Newgrange isn't a lecture about solstices, it's a device. At sunrise on the shortest day, light threads a roof box, slides the passage, and sets a chamber glowing. That's a switch. Winter's minimum flips to the slow return of light. The stakes aren't mystical, they're survival. Planting cycles, livestock management, communal schedule, all get a clock. Miss the season, face hunger. A stone tunnel becomes a regulator of human time, far more persuasive than a shouted decree. You feel it in your bones when the chamber brightens and the crowd exhales. 3 days earlier, something else was happening. Engineers in Cambodia were drawing water where it wanted to go, not where it happened to be. Angkor's hydraulic system is the part of the city we overlook when the towers steal the frame. Reservoirs large enough to act like batteries. Canals routing monsoon excess into storage. Spillways that bleed floodwater downstream slowly enough to spare fields. LiDAR scanning pulls the tangled network out of the forest and the pattern jumps. This isn't decoration, it's regulation. Water turns into a thermal tool. Move enough of it and you cool air, feed rice, and buffer drought. A city becomes a climate manager. Here's where it gets crazy practical. Walk through a stone corridor just before sunrise. Cool air collects low, warm airlifts and pressure changes run like breath through the passage. In dense masonry, that breath stabilizes interiors the way thick adobe moderates heat swings. Now scale the idea. Angkor's channels don't just feed patties, they shape temperature and humidity across neighborhoods. It's city-scale HVAC without a single fan. Maintenance is labor, not fossil fuel. The cost is coordination. The payoff is resilience. So what's at risk in these three? People's ability to predict, to make surplus, to feed cities, to plan work and worship without guessing. The consequences of losing that predictability are immediate. A missed flood cycle, a failed harvest, a migration that empties granaries. Why should you care? Because these aren't just ruins, they're operating manuals for stability. And they keep reappearing in different costumes across continents, which means the ideas are robust. Action is where the story tightens. At Giza, builders choose dimensions that produce specific acoustic behaviors. That's trial and measurement engineering. At Newgrange, a slit above the door becomes a waveguide for light. Someone checked that angle year after year and cut to it. At Angkor, the team takes high-ground reservoirs, steps them, feeds canals, and builds overflow weirs where the land demands it. That's a living control system responding to monsoon pulses. Impact, immediate in their time. Giza's alignments embed authority in stone. A ruler's power fuses with cosmic order. Newgrange's beam turns a crowd into a calendar. The year starts when the chamber says it does. Angkor's water makes a capital that can grow, feed, and cool. Population follows reliability. Ripples, they reach us. Every time LiDAR maps another hidden canal, every time muon scans hint at unexplored voids in a pyramid, the same message lands. Precision wasn't rare. Coordination wasn't luck. Infrastructure wore a sacred mask. But there was one problem. These systems vanish between eras and come back as stories. Workshops dissolve, apprentices die, archives burn, and techniques slide from how to why. The ritual remains. The utility becomes legend. Later, when someone hikes into a chamber and whispers that it feels like a machine, the Academy flinches because the loudest claims overreached. Fair. Ground the language. Call them what they demonstrably are. Instruments of time, of water, of climate, folded into meaning. Meanwhile, unknown to them, across town another crew was hammering copper and sighting stars, turning the sky into a schedule that would steer ships. We'll get there. First, lock this in. Stone, light, and water formed an ancient stack that made surplus predictable. And whenever surplus appears, someone will learn to meter it. Everything was about to change when metal and sky joined the circuit. Ancient Tech 4-6, metal, sky, and signal. While water-cooled cities and stone caught the sun, metal and sky turned time into a tool. Start with a small bronze disc dug up from a German hillside, the Nebra sky disc. It's not flashy gear, it's a plate with gold inlays, a circle, a crescent, a tight cluster of dots, later arcs on the edges. Many scholars interpret the cluster as the Pleiades, a seasonal marker in traditional calendars. The arcs, often read as horizon bands, angular limits for sunrise and sunset across the year. Stakes, timing equals energy. Plant too early, frost kills seed. Plant too late, the hungry season stretches. A village with a reliable sky signal outcompetes its neighbor. Action looked simple and relentless. Each year, observers tracked first and last visibility, then nudged sowing dates, grazing moves, and harvest festivals into sync. The disc wasn't a ritual trinket. It was admin-grade metal, portable, legible, held up at council and pointed like a clock. What nobody knew at the time was that this kind of object stitched communities into the same rhythm, smoothing conflict because the sky made the call. Impact. Surplus stabilizes. When yields rise predictably, you can store, trade, specialize. Gold on bronze becomes calories in winter. Meanwhile, at sea level in the Greek world, a corroded gearwork slept in a wreck, the Antikythera mechanism. Strip the myths and keep the math. Bronze gears modeling lunar cycles, eclipse patterns, and calendrical cycles tied to festivals and games. Turn a crank, get the phases, read off when eclipses will occur, track the Olympiads. Stakes. Navigation windows, religious processions, market days, coordinated across city-states that had to agree on when next month began. If Nebra is a pocket reminder, Antikythera is a desk machine for planners. Watch the workflow. A magistrate or priest turns the pointer, aligns the dials, and posts the date for a sacred game or a tax announcement. Sailors scan eclipse tables to avoid bad omens on departure. The device codifies cycles human eyes already sensed, compressing sky into schedule. Impact, reduced friction. Armies muster when roads and moonlight cooperate. Traders converge when the feast day guarantees crowds. And because the gears hide inside a wooden case, the magic stays with the operator. That's how technology becomes priestcraft. Knowledge concentrates, users lean on intermediaries. While that was happening in workshops, another engineering tradition ran underfoot. Qanats and stepwells, gravity-fed water systems that move supply without pumps. In Iran, engineers cut mother wells into aquifers, then tunneled gently sloped galleries for kilometers, vented by vertical shafts. Water emerges in town cool, clean, and under low pressure day and night. In India, stepwells lowered stair-laced courtyards to groundwater, storing coolth. Yes, cold as a resource in shaded stone. Stakes, heat management. In a pre-grid world, passive cooling is survival. Food lasts longer, bodies recover, work continues at noon. Action is tactile. Surveyors aim grades shallow enough to prevent erosion, just steep enough to flow. Crews dig at night to manage heat, aligning shafts by sighting stars and plumb lines. Walls get lined, channels sealed with lime, and exits shaped to reduce evaporation. The system runs on gravity and maintenance, not fuel. Impact, drought buffers, cooler microclimates, and stable urban footprints. Markets form around the outlet. Craft guilds cluster where temperatures are tolerable. Women, who usually carry water, gain time back when the source sits in the village heart. Here S the thread tying disc, gearwork, and earthworks together. Signal to action. Each tool captures a cycle, celestial or hydraulic, translates it into a schedule, and pushes that schedule into daily life. The stakes keep repeating because they're human. Food, heat, labor, legitimacy. And every time signal turns into control, power follows. Not in a cartoon villain sense. In the quietly decisive way councils decide planting day, priests announce processions, and water masters open a gate on market morning. What nobody knew at the time was how fragile workshop lines are. The disk's knowledge could persist even if the metal vanished because elders remembered the Pleiades rule. The mechanism's knowledge depended on craftsmen who could cut fine teeth, lose the shop, lose the tool. Qanat maps lived in heads and clans, conquer a city, disrupt the maintenance, watch the galleries silt. That's the disappearance pattern. Tech embeds in institutions, institutions crack, the artifact remains, the instructions don't. But there was one problem that would haunt later centuries. When devices become gatekept, their language shifts from public instruction to sacred explanation. The disk moves from calendar to icon. The gearwork moves from office to legend. The Qanat becomes a miracle of ancestors rather than an engineering practice you can learn. That shift makes rediscovery slower and replacement harder. It also hands future authorities a lever: control the signal, meter the benefit. Meanwhile, unknown to them, a new kind of meter was forming, one that didn't measure stars or slopes, but inputs, ownership, and permission. If the ancients built reliable cycles, why did the gears stop turning? It wasn't entropy, it was policy. The next era invented a new lock and turned it. The Suppression Engine: how tech gets buried. To see why the gears stopped, follow the paperwork. The pattern isn't mystical, it's mechanical. First, monopolize inputs, then control standards, classify threats. Finally, discredit the people who won't play along. It starts in the 189s and hardens through the 194s. 196 is when energy stopped being just a commodity and became a lever of statecraft. Monopolize inputs sounds abstract until you watch copper, coal, and oil consolidate. When a few trusts own the wire, the rail, and the wellhead, any device that bypasses those channels looks like a direct attack on the balance sheet. Meanwhile, utilities knit into regional cartels. Interconnection helps reliability, sure, but it also creates gate valves. You want access? Meet the tariff. Meet the intertie rules. Meet the terms that turn competitors into customers. Control standards is subtler. Standards bodies sound neutral, they're necessary, but put incumbents in the room and safety becomes a break. A new turbine can't hook to the grid until it passes tests only the grid owner can run. A storage medium is non-standard, therefore ineligible for capacity payments that make financing work. Months turn into years, investors drift. The tech ages out without a single headline. Classify threats arrives with a statute number. Section 181 of the Invention Secrecy Act lets the government place a secrecy order on a patent application when disclosure might harm national security. The intent is understandable: missiles, cryptography, dual-use materials. But the list of flagged, energy-adjacent subject classes can be broad. Radiant energy converters, advanced thermionic devices, high-density storage chemistries with potential defense interest. The order arrives, the clock stops. You can't publish, you can't raise, you can't even talk except to the office that issued the gag. What nobody knew at the time was how sticky those orders become. They renew yearly quietly. The numbers don't scream, they simmer, thousands active in some years, a steady baseline that barely makes the news. When the veil finally lifts decades later, the market has moved on. The inventor's estate gets a polite letter. The window is gone. Discredit the people is the final, reliable move. If you can't block the circuit with a standard or a secrecy order, make the lab look unserious. Plant a narrative: it's fringe, it's unsafe, it's perpetual motion in a new suit. Find a failure because all prototypes fail and amplify it. Or better, tie the person to a myth you can swat. Free energy, ancient aliens, whatever makes a serious engineer stop returning calls. Funding dries, papers stall. The Whisper campaign does what a lawsuit couldn't. Here's a micro story that hurt to read. A mid-century engineer, quiet, methodical, files for a high-efficiency heat-to-electric converter. Not a miracle, just an incremental edge at scale. 6 weeks later, a brown envelope, secrecy order. His correspondence goes gray. No more conference appearances. Trade journal mentions end mid-sentence. His daughter finds the patent number 30 years on. The order was lifted after he died. In the margin of his notebook, if I can't publish, at least build one that runs the shop. The shop is long gone. Meanwhile, something else was happening. The standard's language itself became a moat. Grid interconnection rules grew thicker. Noise limits, harmonic distortion, islanding protection, each one sensible. Together, they form a labyrinth only incumbents can navigate cheaply. Startups spend their runway learning paperwork, not improving devices. A competitor calls that market discipline. It feels like gravity with a lawyer's name. What about the 1940s, 1960s consolidation? Utilities standardized on big thermal generation. Coal and later gas plants fit the financing models of the day: predictable, central, metered. Anything that doesn't slot into that template gets treated as an outlier. District energy considered a curiosity. Waste heat capture framed as boutique. Thermal storage waved off as not dispatchable. The result isn't a conspiracy. It's a spreadsheet that only recognizes one category of answer. But there was one problem. The secrecy machine built for bombs doesn't have a dial for nuance. Dual use became the catch-all. High energy density capacitors, useful for pulses, weapons, grid smoothing, so into the vault. Bioelectrochemical cells with defense interest, into the gray. Even heat pumps, the most boringly effective tech in the room, struggled to count as power in rules designed around combustion. Impact shows up as decades of delay compounding into dependence. Regions never build district-scale cooling because the first pilots die in permitting. Storage vendors miss capacity payments, so they can't scale to the price point that would win. Entire universities quietly steer PhD topics away from classified adjacent traps. The public story becomes, nothing works. The private file reads, not allowed to say if it did. Here's the stakes check. What's at risk is time, the one resource you can't replace. Every year a patent sits under order, an engineer retires without training a successor. Every standard that excludes a class of devices writes a ghost story for a town that might have had affordable heat. Every safety op-ed ghostwritten by a lobbying shop buys another quarter for assets that should be stranded. So no, the gear didn't stop because people forgot how. The lock clicked because policy taught the market to prefer one shape of machine. And once a meter is on the wall, anything that threatens the meter will meet the gate. The 12 technologies, the list they don't want. 12 pieces, one spine. We're not chasing miracles, we're naming systems with plausible mechanics and a paper trail. 5 ancient, 5 modern, 2 hybrids. Each one threatens a meter. Each one leaves fingerprints. Ancient stack number 1, hydraulic cooling grids. Think Angkor's waterworks upgraded for dense cores. Stone, channels, shade, and mass moving heat the way a heat sink does. Stakes. Urban comfort without combustion. Action. Stacked reservoirs, night-flushed canals, courtyards that trap cool. Markets positioned where air moves. Impact. Lower peak temperatures, steadier food storage, fewer deaths in heat waves. Meter threat. Cooling without kilowatt hours. Number 2, solstice-locked solar corridors. Newgrange isn't unique. Light-gated spaces show up across latitudes. The mechanism is geometry, roof apertures, and aligned passages that turn the sun into a switch. Stakes, calendar certainty, action. Builders fix planting and ritual to a physical moment. Impact, coordinated labor, farming, taxation, and migration cycles that don't drift. Meter threat, governance powered by sky, not by a clock you sell. Number 3, resonance-assisted stoneworking, clearly flagged as hypothesis. We stay careful, evidence, repeated acoustic behaviors in carved volumes, tools and polishing methods that suggest vibration mattered. Stakes, labor efficiency and precision. Action, tuning cavities to amplify hand tools and rhythm, not lasers in a tune. Impact, faster shaping, fewer fractures, tighter fits that stabilize interiors. Meter threat, a craft upgrade that scales with skill, not fuel. Number 4, eclipse calendars as social power. Nebra is our stand-in, a portable, legible signal device translating sky into schedule. Stakes, agricultural timing and legitimacy. Action, councils hold metal up, sowing starts when the cluster returns. Impact, fewer famines, synchronized markets, less conflict over missed moons. Meter threat, timing sold by the heavens, not a sanctioned registry. Number 5, gravity-fed pressure systems, cannots and stepwells. Mechanics are textbook, shallow grades, lined channels, shaded storage. Stakes, day and night supply, passive cooling. Action, survey, dig, maintain. Impact, stable towns in brutal climates, microclimates for craft and trade. Meter threat, continuous flow without pumps. Modern stack 6, solid-state thermal storage, bricks, carbon blocks, concrete. Off-peak electrons, heat mass returns steam or hot air on demand. Stakes, converting cheap, variable power into reliable process heat. Action, charge overnight, discharge at noon, no exotic chemistry, just refractory material and heat exchangers. Impact, gas displacement in kilns, dryers, food, and paper, costs at or below fossil baselines. Meter threat, kilowatt hours that become heat behind the fence, slashing gas throughput. 7, industrial heat pumps. The quiet bulldozer, mechanics, vapor compression with upgraded refrigerants and multi-stage lifts. Stakes, process heat up to mid and even high temperature bands. Action, harvest waste heat, step it up, feed lines without burners. Impact, 30+% source energy savings, immediate emissions cuts, capex that pencils with power contracts. Meter threat, fuel sold as electrons, not molecules. Incumbents lose a lever. 8, supercavitation turbine concepts. Not sci-fi, leveraging vapor cavities to reduce drag in liquid machinery. Stakes, higher efficiency in certain hydro and pump regimes. Action, geometry that sustains stable cavities, materials that survive. Impact, incremental but compounding improvements in water-to-power and power-to-water flows. Meter threat, less fuel per unit moved. 9, high-density ultracapacitors. Honest lane, best-in-class power density now. Research pathways push energy density upward. Stakes, smoothing, fast cycles, peak shaving. Action, pair with thermal storage and heat pumps, shave spikes, avoid demand charges. Impact, extend asset life, enable microgrids, stabilize renewables. Meter threat, fewer excuses to keep spinning reserve burning fuel. 10. Bioelectrochemical fuel cells. Microbes turning chemical gradients into current. Stakes. Wastewater plants becoming power plants.